This video will be about a segment of the Introductory to Mathematics on Engineering Applications. This segment of engineering applications will be about complex numbers. Here we have a question. The circuit is shown below. It consists of a resistor R and an inductor L and a capacitor C. The impedance of the resistor is Z1 equals R. The impedance of the inductor is Z2 equals J times ohms times L. And the impedance of the capacitor is Z3 is equal to 1 over J times ohms times C, where J is equal to the square root of -1. The question goes on to say, for a low-pass crossover design, R is equal to 25 omega, L is equal to 25 millihertz, which is 10 to the -3 in henries, millihenries I meant to say, and C is equal to 5 microfarads, which is equal to 10 to the -6 farads, and ohms is equal to 1000 pi radians per second. The first question asks us to express the impedance for Z1, Z2, and Z3 in both the rectangular and polar form. Here, the first thing I would do is write down all of the givens. And then, after you have all of the givens, substitute the variables inside of each given for the actual number that's also given. As you can see, for solution A, Z1 is equal to R. So therefore, Z1 is equal to 25 ohms. Z1 is equal to 25 plus J times 0 omega in rectangular form. The polar form is as such, 25 angle 0 theta. 25 angle 0 degrees, ohms. For the rest of solution A, Z2 is equal to J times ohms times L. Z2 is equal to J times 1000 pi, because 1000 pi was said to equal the ohms, and 0.025, which was converted to regular henries from 25 millihenries. And that simplified to J times 78.540. I went out to 3 significant figures. Here, to simplify it even more into its rectangular and polar form, J 78.540 ohms, which was just about the same thing, we just added a unit. Polar form would look like this: 78.540 angle 90 degrees theta. Degrees. It's 90 degrees because there's a J component here, but it's not necessarily a specified angle. There's only one component, so we just implied that the angle was 90 degrees. Z3 is equal to 1 over J ohms times C. So Z3 is equal to 1 over J times 1000 pi times 0.000005 farads. It's simplified to 1 over J times 0.0157. If we divide the two numbers given, we come out with -J times 63.662. Again, 3 significant figures to stay consistent. The rectangular form of this will look like this: Z3 is equal to -J 63.662 ohms. Polar form will look like this: 63.662 angle -90 degrees theta. -90 degrees ohms. I'm sorry again. Here we had a -J component, and therefore we assume that the angle would be a -90 degrees rather than a positive. So that's it for question A. Question B says, compute the transfer function h of the crossover as given below and express the result in both rectangular and polar form. For solution B, it will look something like this. After substituting in all of the givens, H would be equal to J times 78.540 plus negative J times 63.662 over 25 ohms plus J times 78.540 plus negative J 63.662. If we simplify the two J components on top and on bottom in the numerator and denominator, we can simplify it to 14.878. So on top, since we still only have one component, which simplifies to 14.878 angle 90 degrees, we put it in polar form so it'd be more simple to divide. In the denominator, we had two components. One was a J component, one was an X component, or a Y component and X component. Because we have two components, we can find the resultant or the hypotenuse. So we say 25 squared plus 14.878 squared, and the square root of that will give us our hypotenuse. And we take the Y and the X component to find the angle. So we say arctan of 14.878 over 25. To simplify it, we got 14.878 angle 90 degrees over 29.092 angle 30.757 degrees. And because the question asks us to write it in polar and rectangular form, we came out with H is equal to 0.511 angle 59.242 degrees. H is equal to 0.511 cosine 59.242 degrees plus 0.511 sine of 59.242 degrees in Euler's method. We put it in Euler's method so it'll be easier to convert back to rectangular form. After simplifying the equation, H is equal to 0.261 plus J times 0.439. That's it for question B. Question C was rather simple, more simple than the others. It says determine the complex conjugate H prime and compute the product H times H prime. Here, solution C says to find the complex conjugate. All you have to do to find the complex conjugate is change the addition sign to a negative sign. And this is your complex conjugate. To multiply the complex conjugate times the regular expression, we can simply put them side by side and recognize that it's a polynomial, which we just have to FOIL. That simplified to 0.261 squared minus J squared 0.439 squared, which simplifies to H times H prime is equal to 0.261. There is no unit. And that is the conclusion of the question. Thank you.